Hello, in this video series I'll be showing you how to create springs with Solidworks from simple straight to complex and deformed. If you find value here, please like, subscribe, Patreon, buy merch, or buy from affiliate links if you see any. Alright, on to the video. So now if I want to be able to change the diameter of the whole spring or of the wire, we have to add those functionalities as well. Actually, the wire should be fairly easy, the wire diameter, but we'll look at that after. So right now, looking at the spring diameter, right now we have a dimension here of a 1/2 inch, but that's not really defining it. What is defining it is this 1/2 inch in this sketch. I hesitate because I could actually cheat and I could move this way and it would increase the diameter. There's almost not a good reason to not just do it that way, but let's do it properly so it's easier to control and it'll be a simpler model. So I basically need to undo that, get rid of that constraint, allow that to move off, and I do want to again project this geometry with the G key. Oh really? It let me before. Isn't that interesting? It let me before. Huh. Very strange. Well, be that way. I will beat the software. Discard and exit. And I will roll back to way back here. I will create a 3D sketch and project that path onto it. That should allow me to well, I won't project it, I will just put the circle center point on that 3D sketch helix. So create Control 3 creates a 3D sketch. You can see I am now in a 3D sketch, and select this path. G for convert geometry, R for rebuild, and I will hide this and I will show my sketches. And so now this is a sketch entity, not a path. And so now, pardon me, drink of water. And so now I will roll to the end again, and I will select this sketch, and I will get rid of this anchor point fixed, and I will now attach this to this 3D sketch curve, rebuild. So now if I change this diameter, it should update properly, and it does. Let's turn off the sketches. Let's put a nice nice looking chrome plated finish on this. So now we have all that, and of course we can change. I just did a little integrated preview there to make it look realistic, just for the fun of it. And so if I change the wire diameter, well, that's a little trickier animal actually. If I want the ends to be complete as they are here, we'll look at that in a later video. So let's say we want to change the wire diameter and we want this spacing to still be proper. That is another animal here, and so let's take a look at how to do that. So if let's see, it's down to this sweep, in this circle. So let's say I went 0.07, 70 thousandths diameter, rebuild. So now we have a gap here, and so we have to fix that gap, and we have a gap here. We want those to be lined right up. So that comes down to our equation for the spacing, and also for this pitch on here. So this needs to be, this number, the pitch, needs to match the other diameter. Although we'll end up with that artifact, we'll beat that artifact of the missing face afterwards. Yeah, I know how I can fix that. Okay, so let's go back to this diameter here. Let's edit this sketch, so that way I can select this, copy this sketch, this dimension name, Control C, D1 at sketch 3. That way I can paste it into an equation here. So my helix here, helix here, double click this, and I will make this equal to quote, paste, quote, that. So now that will be an equation. You see this summation symbol. And so now that changed the pitch as such. But now my overall height is incorrect because these numbers were just for that 0.1. Okay, so oh wait, yeah, so this number is just 0.1, and it should not be. It should be that diameter also. So that should be equals space quote paste quote. So that wire diameter is now that offset. And that puts that up there, and so I need to again adjust this. So I think initially I said 1.5, and I think that was correct. So now, although I do have, see, we have this artifact here, and so what I can do is, if I, just to cheat the system here, if I go to, before I cut this end off, and I just offset, oh, that's interesting. But anyway, if I move face, so if I go features, move face, and select these faces, and just move them by just a thousandth of an inch. Well, I can't tell which way it is, so let's say 30 thousandths, just to see. Okay, flip direction, there we go. Alright, so 0.001. So that takes 2 thousandths to finish off the diameter. And so that may make it much happier. So the reason I did it that way is so now we can punch in the real number. So when I put in my diameter on here, I can type in the true diameter, and the equations will work properly, and then it will just move that face slightly just to eliminate the slight interference that caused the problem. Now we do have this issue going on here. Must be because of the move face, or maybe, let's see what happens if we edit it. Oh, these got out of line somehow. So let's line these green points back up, and we should be good to go there. Okay, so now we can adjust the diameter of the spring. Let's call that 1 inch. And this should have gone through both. Oh, Aha. Not wide enough. Okay. So we can adjust the diameter of the spring. We can adjust the overall height. We can adjust the wire diameter. And everything behaves quite nicely. These lofts at the ends could eventually cause a minor problem, but they seem to be pretty robust, so I won't go much into it. So that's it for that. Now, what if I wanted to increase the number of coils? Will that change anything? I should be able to, if I just change that to 4. Yeah, okay. That worked out. Alright. So, now, what if, well, before I get into that, so now you can see the nice thing about this is I could in a configuration, I can say add a derived configuration, free state length, and description length of the spring when with no force applied. Right? And then I could say add a configuration for deflected 1, and then another for deflected 2. And so then this dimension I could say oh no, I'm sorry, this dimension I should be able to say configure dimension, and so it shows the 3 different, or shows the 4 different configurations. So if the free, let's call the free state length 3 inches and the deflected 1 at 2.5 inches, so that would be a half-inch deflection, and so depending on the spring rate would be a given amount of force required. And then if I go down to 2 inches, that would basically be double the force, just about. I mean, these springs tend to be just about linear in their force values, and so I can say OK here, and then I could go into my configurations and say free state length. Oops, I can activate free state length. I can activate deflected 1 length, deflected 2. So now we have a very powerful model that we can actually use this in an assembly and show it at multiple states. So it's pretty easy to create a spring that looks like a spring. It's another thing to create a spring that's useful and looks correct in an assembly. And that's what we've done here.